Okay, question 3. In the diagram, AD is equal to DC, BE is equal to EC. The coordinates of D are 3 and 0, and B negative 3 over 2 and negative a half are given. The length of AB is equal to 8,5 centimeters. Find the gradient of AB. Usually when we find the gradient, we use the gradient formula. M is equal to y2 minus y1 over x2 minus x1, but that's if you have 2 points. If we look at line AB and what we've given, we do not have 2 points on line AB, so we can't use that formula. If we can't use that formula to find gradient, we usually look for words like parallel and perpendicular to see if there are any lines that are parallel or perpendicular given, and use that to find the gradient. But here in this case, we don't have anything parallel or perpendicular to AB. So we now go to the equation m equals tan theta. If you look carefully along the line AB on the x-axis, you'll see an angle there of 45 degrees. That's your theta angle. So m will equal to tan of 45, which is equal to 1. 3.2, find the equation of DE. If we look at where DE is, we'll notice that DE is actually parallel to AB because of the midpoint theorem. So we know that the gradient of AB is 1. It means now that the gradient of DE is also 1 because parallel lines have equal gradients. So our equation of DE then becomes y is equal to 1x plus c. We substitute a point that's on DE, in this case it's point D, which is 3 and 0. And we work out our c, which is negative 3. So our equation of DE becomes y is equal to x minus 3 now. 3.3, find the length of DE. Again, from the midpoint theorem, the length of DE is actually equal to half of the length of AB. So DE will equal to half of 8,5 centimeters, which is 4,25 centimeters. 3.4, find the coordinates of F if ABCF is a parallelogram. Okay, if ABCF is a parallelogram, if we join BDF as a straight line, BF will be the diagonal, with D on that diagonal being the midpoint. So to find the coordinates of F, we're going to use the midpoint formula to find the coordinates of F. We will break up the midpoint formula into x1 plus x2 over 2, and that is equal to the x value of the midpoint given, which is 3. So x1 plus x2 over 2 will equal to 3. Then we do a separate equation, y1 plus y2 over 2, and we make that equal to the y value of the midpoint that's given. So y1 plus y2 over 2 will equal to 0. Okay, so our b coordinate is negative 3 over 2 and negative a half, that's x1, y1, and our f coordinate is x and y, which is x2, y2. Substitute all of those into the two formulas that we've just made, and you will work it out, and x becomes 15 over 2. So there is a little bit of cross multiplication involved here, but it's not too bad. Like the 3 there can go over 1, cross multiply that and solve for x, you'll end up with 15 over 2. Same goes for the y, calculation of the y, put the 0 over 1, cross multiply and solve for y, you'll get a half there. So your f coordinate then would be 15 over 2 and half. 3.5, find the length of CF. Now CF would be the exact same length as AB because opposite sides of a parallelogram are equal in length. So the CF would then be 8,5 centimeters, the same as AB. Okay, 3.6, find the coordinates of A. Right, if we look at where A is, we don't know too much about A there. We just know that it's the intersection of two straight lines. Not too much else is known about A. We don't have any coordinate there. So let's find the coordinates of A then. We know that A is on line AB, and we can find the equation of AB. We have the gradient of AB, which was 1, we calculated earlier, so we can substitute point B into y equals mx plus c with the gradient of 1. So b is negative 3 over 2 and negative a half. Substitute that into the equation and you'll work out c is positive 1. So the equation of line AB then we can get easily to be y is equal to x plus 1. We need another equation here because we don't know the x or the y value for A, the coordinates of A, so it has to be a simultaneous equation here. So we have equation 1 there from the equation of AB. We can get equation 2 using the length of AB, which we will do now. Right, the length of AB or the distance of AB we know is given to us as 8,5 centimeters. So we can use the distance formula with points A and points B, where we can call point A x1, y1 and point B x2, y2. Fill that into the distance formula, which is equal to 8,5 centimeters. Square both sides to get rid of the square root, and you have your second equation there. We can substitute equation 1 into equation 2. We had there y is equal to x plus 1 in equation 1. So wherever we see y here, we'll replace that with x plus 1. Okay, which we have done. We open everything out there. We square the binomial of the first one. Oh, in fact, it's a bit easier this one. We don't need to square the binomials because the second bracket there simplifies to negative 3 over 2 minus x. So is the same with the first bracket. It's also negative 3 over 2 minus x. So we have negative 3 over 2 minus x all squared plus another negative 3 over 2 minus x all squared, and that's equal to 72,25. It means that we have two brackets that are negative 3 over 2 minus x all squared. That's equal to 72,25. So the next line I would actually divide both sides by 2 to get rid of the 2 in front of that bracket. Okay, and I'll continue then by square rooting that bracket to get rid of the square. So I'll square root both sides. Then I'll have negative 3 over 2 minus x is equal to the positive square root of 36,125, and x there works out to be negative 7,51, or I'll have negative 3 over 2 minus x is equal to the negative square root of 36,125, and x works out there to be 4,51. If we look at the position of A, the x value there for A is on the positive side of the x-axis, which is why we ignore the first answer and we take the second answer there. So the x value would be 4,51. We substitute that into equation 1. Y is equal to 4,51 plus 1 now, and y is equal to 5,51. So my coordinates for A are 4,51 and 5,51, solved simultaneously.